Topic 4-1, parallel lines and transversals. You can reference this with our Holt textbook, Chapter 3, Section 1, on page 146 through 151. Another site, I'll mention it again, www.math is also going, I'm going to show some things during this lesson that you can use, look at some animation. Okay, let's start with definitions. Parallel lines. In the same plane, a line that's in the same plane that does not intersect, they have the same slope and are equal distant. When they talk about equal distance, they mean the distance here to here all the way, continuing in this direction and that direction, denoted by the arrows. Sometimes they're filled in arrows and sometimes they'll just be an open arrow. That denotes parallel lines. So that L and M, if we labeled it, would be parallel to each other. Skew lines. Lines not in the same plane, and they're not parallel and they do not intersect. So drawing the diagram three-dimensional, now it's already drawn. Sometimes I teach kids how to draw a rectangular prism. If you'll draw a rectangle, and then draw another rectangle similar in shape, slightly higher and off to the right, connect the top to the top and the bottom lines to the bottom lines, you can actually make a three-dimensional figure. Okay, when they talk about skew lines, you have to be careful. They're not parallel and they would not intersect. So they're drawing a line on one that's on this plane. When you're thinking about the plane, it would be a line that takes the place of this plane here. Well, a line that would not be parallel and would never intersect that line could be, and I'll draw mine a little bit different than that one, that would be one like this one. We could draw it in dotted, kind of a dotted look. So that this hits this plane, but it's never going to intersect and it's not parallel, so it's too skew. If you want to see that three-dimensionally, I've got it in a figure. You've got a plane like this, you turn it up, that would be like this line here, which is at the top, and then one of these lines at the bottom. So again, one that would not be parallel, and they would never cross each other. I guess I could show it with two pencils, like this one and that one. I'm going to try to hold this up. That one where the green line goes, and then this one along that plane there. Notice how they would never intersect each other. It's easiest to see it that way. Skew lines. Parallel lines, planes that do not intersect. So again, if you draw a rectangular prism, you can shade the top and the bottom of your picture that you've done. This would have two parallel planes. Highlight a little bit darker. So these are parallel to each other. That would be the same as taking a couple of playing cards. If I had two playing cards and lined them up like that. Parallel lines. These could be parallel planes that don't intersect, and they are parallel, trying to make parallel as best I can, parallel to one another. Okay. Here's an example using this figure below to answer the questions that follow. What lines in the plane AB, parallel to AB? Well, if this is AB, lines that would be parallel to it would be DC and EF. These two lie in the same plane and that share EF, AB, but this one shares the plane A, B, C, D, so that one's also parallel. So you got to make sure you use symbols when they ask for lines. If they say lines, just show it with an arrow going both directions. What are other sets of parallel lines? Well, DE is parallel to CF. There's several more. DA is parallel to CB, and line EA is parallel to FB. So take a minute and showing this is the symbol for parallel. Two lines without any arrows, just straight up and down. A lot of times I stress that the name parallel has the two L's on the inside of the actual word. So denote it with two lines going straight down. Name a pair of skew lines. Sometimes this is a little harder to do, but look at closely. DE would be here, and AB would be here. On a flat surface, yes, they would appear to cross. But if it's a three-dimensional, I think I've got a prism. You can look at it. Here's a 3D figure that if you're going along the back side, it would be like showing this one, and that would never cross or intersect or be parallel to that one. Kind of hard to see these. That one and that one. They're never going to cross. Okay, move it around. Those are skew lines, but you're often only going to see it in a flat piece of paper that shows 3 dimensions. Name a pair of parallel planes. Very different than lines. It's the parallel planes. And so in a plane, you have to denote it by 3 letters. DEA, we could actually go back to our shading, could be this whole plane right here, and it is parallel to CEF. And none of the other planes are parallel. They all connect to one another, so there's not another plane that's actually parallel. You would have had to have a prism to be able to do that. Okay, let's move on to transversals. A transversal is a line that intersects 2 or more lines in a plane at different points. We're not talking about parallel lines yet. That'll be the next section. This one, however, is considered the T is the transversal of line L and N. It's because it cuts through both of those lines. So when 2 lines are cut by a transversal, several types of angle pairs are formed. All right, we're going to talk about the interior and exterior before we go any further. Let's get rid of the plane. Interior, the inside, would be like all of these on the inside. So I'm going to shade that inside plane. So this would be the inside, interior. The exterior would be the ones on the outside. So we'll shade those blue. This is the outside, and this is the outside. Sorry, this paper seems to shake. I hope that's easy enough to see the difference in color. Make this a little darker. There's your green. The green is the interior, the exterior is the blue. Okay. Alternate interior angles are 2 non-adjacent interior angles on opposite sides of the transversal. You can always denote the transversal with a highlighter if you'd like. So that is your transversal. So if you are going to alternate, that means you're going to take one on the inside, 2, hop over the transversal and go to the other side. So 2 and 7 are alternate interior angles, as well as 3 and 6. The transversal that those 2 are denoting is transversal line Z. That's why we put the Z there also. Alright, alternate exterior angles are 2 non-adjacent exterior angles on the opposite sides of the transversal. So again, the highlighted yellow line, or now in the blue section for exterior, we hop over 1 and 8, and 5 and 4. So those are both going to be denoting each of the exterior. Same side interior and exterior, you got to be careful. Interior and exterior angles on the same side of the transversal. First, let's name the exterior ones. Well, I guess I'll leave that down. 1 and 4 are on the same side. They didn't flip over. They're same side of that yellow line. Those are exterior, though. They're in that blue area. Hop over and look at 5 and 8. Those are also exterior. The interiors would be 2 and 3 on the same side inside the green area, and 6 and 7 would be the interior on that side. Same side again. I'm not sure exactly what that is. Oh, let's move on. Corresponding angles. Two angles that are in a similar position relative to the lines and the transversal. So again, this one's sometimes the hardest one to denote, but we're not talking about parallel lines, so we're not talking about congruency yet. But corresponding in the same similar position relative to the transversal would be 1 and 3, 5 and 7, 2 and 4, and 6 and 8. And those are your corresponding angles. Okay, let's go on to the last example in this section, and that is using the figure below to classify the angle pairs and determine the transversal that forms them. Okay, this can be a transversal for C and D. B can also be a transversal for C and D, but then you could also have C being the transversal for A and B, and D being the transversal for A and B. So let's look at the different angle pairs. I left some blanks on your notes, topic pages, so we're going to fill them in. The first one, the corresponding ones I filled in for you. 1 and 5. 1 and 5 are on the same side of the transversal. Which transversal denotes that correspondence? That would be transversal C. All right, looking at 4 and 6. I'm going to try to do this with 2 pencils. If you've got 4 and 6, I'm not going to highlight it because it changes all the time. But if you look at the transversal is the line that includes both these two lines. It cuts them in two. Well, cuts through them. And that would be transversal C. But it's alternate what? Are they on the inside or the outside? They're on the inside. So we'll denote that abbreviation. Interior, I-N-T, cut by the transversal C. And the transversal, I think I made a note on yours too that this is a line in common. You've got the line in common to both of the lines that they're talking about. So 4 and 10. There's 4 and there's 10. Now, if you look closely, the transversal that includes both of these is transversal A. And again, look closely. Are these on the outside of that transversal or the inside? Exterior would be the outside. Abbreviate that. E-X-T, exterior. 2 and 9. Again, I've helped you out here, but we want to know which one. Is it same side interior or same side exterior? So 2 and 9. Here's 2 and here's 9. They're both in the inside of the transversal A. So they would be considered same side interior with the transversal A crossing them. I gave this one to you again, 4 and 12. They're not parallel this time, although they appear to be parallel, but we're just looking at transversals and their angle pairs. 4 and 12 would be corresponding with the transversal A. 3 and 9. 3 and 9, with which line cutting in between both of them would be transversal A, and they are on the alternate interior. I-N-T, period. 2 and 7. 2 and 7. These are on the outside, cut by the transversal C, so that's alternate exterior with transversal C in common with both of them. 2 more. 3 and 12. 3 and 12. They're both on the inside. They didn't cross over, so they're same side, but are they on the inside of this A or are they on the outside? They're on the inside. So that's transversal A, interior. 1 and 7. Here's 1, here's 7. You've got, they're both on the same side. They didn't cross over the transversal. They're on the same side, with this one cutting them in half. So they're on the same side, but they're to the exterior. So this is exterior with the transversal C. To show you the different things on the math, let me get to it real quick. It talks about pairing interior and exterior angles. See if I can get to it. I already had it. Oh, internet problem. Just a minute. Let's see. Well, mathisfun.com, you can actually, I'll just show, let's see if I'll get to it. It's still trying to find it. Auto tune. It's the first time I've actually referenced with the computer. Bear with me. Okay. Interior angles and exterior angles. This is just too bright. Now, come see me and I'll show you exactly where that is on your computer to be able to let you move lines around and figure out differences of complementaries and supplementary angles. We'll get to that too.